Hi, welcome to this presentation on IBM Spectrum Fusion. This presentation is going to be a high-level technical introduction to Spectrum Fusion. Now remember, Spectrum Fusion is a container-native, software-defined storage for Red Hat OpenShift and Cloud Paks. It provides robust data services and global data foundation for all OpenShift applications, and it's built from proven IBM Spectrum storage components. This presentation, Sumant is going to go over some of the core capabilities, including who Spectrum Fusion is designed for, the different deployment models, what application definitions are, how the global data fabric plays an important role, what type of data protection is provided, as well as high availability and disaster recovery. So with that, I'm going to go ahead and turn it over to Sumant.
My name is Sumant Patbidri, and I'm the lead architect for Spectrum Fusion. And I'll go into a little bit more technical detail about Fusion. Spectrum Fusion is a data management platform for Kubernetes applications. So before I get into the technical details of it, just want to introduce the personas that Fusion is designed for. The personas are mainly the Kubernetes or OpenShift administrator and an application developer. As companies are modernizing their applications and moving them to Kubernetes, moving them to OpenShift, what we are finding is that there are more and more stateful applications that need to run on Kubernetes. These are applications that are heavy consumers of persistent data. These could be applications like databases, for example. A lot of AI, ML applications that need to access this data to analyze the data, gain insights from it. So there's a huge need for storage management for stateful applications in Kubernetes. And you'll typically run into two personas there, like I said. There's the Kubernetes admin, the OpenShift admin persona, who wants to build a reliable, trustworthy platform that can protect data, can protect applications from disasters, go back to previous backups, etc. Then there's also the application developer who is working on moving their applications to the new platform, to Kubernetes. And as they do that, they want to be able to specify what type of storage their application needs. Some applications may need fast storage. Some applications may need to share data across clusters or even across sites in a hybrid cloud model. So these are the two main personas that you'll be running into. I just wanted to introduce those to you before I dive into the details here. Fusion is provided in a way that makes it possible to deploy it in many different places. We don't have all of that today. Some of this is coming. Today, what we have is the Spectrum Fusion HCI platform, which is a hyperconverged infrastructure box. And I'll talk a little more about that in the next slide here. If you're deploying OpenShift on premises, HCI is a great platform because you can get OpenShift and Spectrum Fusion out of the box, built using best practices, tested by IBM, so you don't have to go build your own solution and figure out all these problems by yourself. We also just introduced the software-only version of it that runs on OpenShift on VMware, and we'll pretty soon be adding many more platforms, especially in the public cloud domain. So the idea is that no matter where you run your applications in your hybrid cloud model, whether it's on premises, whether it's public clouds, or whether you're building a cloud-like infrastructure on premises, whether it's on the edge, you have data management services available everywhere. This slide talks a little bit about the Fusion HCI platform. It comes with a minimum of 6 nodes with 2 disks each, but it can scale up quite a bit. Each HCI rack can scale up to 20 nodes, and then each node can scale up to 10 disks. So it can be quite storage rich. You can also decide whether you want some of those nodes to be compute-only nodes. So maybe what you can do is use a few of the nodes to provide storage and dedicate the rest of the nodes to run your compute workloads. And you can also scale up the HCI platform to 3 racks. You can either use 1 rack or 3 racks. So you can scale up to pretty large numbers using the HCI platform. We have talked about applications moving to Kubernetes. So we wanted to make an application the very central concept in Spectrum Fusion. The very first thing that you would do in Fusion is define what an application is. So what are the microservices that make up an application? What are the resources that belong to that application? What are the data consistency requirements for that application? So step number one is you figure out what an application is. Fusion does a lot of that automatically, but in the future, we'll also be providing ways to make that configurable so that really complex applications that span multiple clusters, for example, can be modeled. And once we have an application definition, now we can do things with it. You can back it up, you can restore it, you can say it needs to participate in disaster recovery. We'll be providing data classification capabilities so that you can figure out what data is there, apply some governance models to the data, etc. So that's a very, very core concept. Once you have figured out what your application is, you can then start deploying it to Fusion in a hybrid cloud type environment. What that means is an application doesn't exist by itself, generates data. That data may be consumed by other applications. Those other applications may not be running in the same cluster or even the same data center. It may be running in other locations. Data may be coming in from the edge that needs to be consumed on premises. What we really need is a global data fabric where applications may be deployed to multiple different places, but have the ability to share data across these locations. And that's the vision of Spectrum Fusion. That's one of the key differentiators that Spectrum Fusion is going to have over the competition. Not all of this exists today. Today, we have the ability to import data from NAS filers, from S3 buckets, from an existing Spectrum Scale or ESS cluster. This is the bottom side of the picture here. And as we move forward, we are going to be providing data sharing capabilities where you can share data between on-premises and edge and on-premises and cloud and vice versa. A key attribute of an enterprise class production ready data management platform is data protection. So when you deploy applications, you want to make sure that you can back it up on a regular interval so that you can go back to a known good state at any point in time if something bad happens. Data protection is quite complicated in a Kubernetes environment because in Kubernetes, there's no inbuilt way to get a consistent snapshot of the application that can be backed up. And that is extremely critical because when you restore the backup, you want to make sure that the data that has been restored is consistent. So the application goes back to a known and consistent state. This is extremely complex in Kubernetes, and this is one of the key features that we provide in Spectrum Fusion, where you can take application consistent backups of the data that the applications use. And there are a couple of ways to do that. One traditional way is you quiesce the application, do the backup, and then unquiesce it. And that can be pretty disruptive to applications because when you quiesce it, the application may not be available. So one very key differentiating feature that Spectrum Fusion provides is we can do what is called a crash consistent backup that has zero impact on the application. So with zero impact on the application, we can take a consistent backup of that application and be able to restore it later. That crash consistent backup capability is a key differentiator. Our competition doesn't do that. I want to talk a little bit about how we achieve high availability in Fusion. We use the tried and tested technology from Spectrum Scale. And here's how we deal with high availability in Spectrum Scale in the Erasure Code edition. Any chunk of data that we need to write, we break it up into slices, and then each slice is written to what is called a recovery group. So your cluster is divided into recovery groups. Each recovery group has a set of nodes. Each node has some disks in them. And each slice is written to a recovery group. And then within that recovery group, that slice is spread across all available disks using an erasure code algorithm. That could be 4 plus 2p, 4 plus 3p, depending on configuration. So what happens here is every chunk of data is written across all recovery groups, across all disks, so we can achieve an extremely high level of parallelism. And that also gives us quite a bit of redundancy so that we can tolerate failures. We get extremely high performance with redundancy here. This shows how we use that capability to get availability for the Fusion HCI platform as an example. So on the right side of the picture here, you have 3 racks. And what we do is we spread these availability groups across the 3 racks in such a way that we can actually tolerate an entire rack going down. Once a rack goes down, performance might get impacted because you have 1/3 the number of disks now available, but your applications continue to run. You don't take an outage even if an entire rack goes down. Just some introduction to how we achieve high availability. It's a very highly available platform. We are also building disaster recovery into the platform. Today, you have the capability to stretch a Spectrum Scale cluster across multiple sites and be able to tolerate a site going down. We are leveraging that capability in Spectrum Fusion to provide multiple levels of disaster recovery capability. For example, in the middle picture here that you see, you have 2 sites, A and B, both within the same metro region, but with Spectrum Fusion at the bottom stretched across both of them, doing synchronous replication so that if one of these sites goes down, the other site can take over with an RPO of 0. And RPO stands for Recovery Point Objective, which is a measure of how much data loss you're willing to take. So in this configuration, you don't take any data loss. It's a RPO of 0. Now this works within a metro region because doing a stretch cluster with synchronous replication requires really good networking bandwidth that is typically feasible only within a metro region. But if you want to implement DR across cities, across countries even, what we'll be building in this is what we call regional DR, where we can synchronize the data asynchronously across sites, even across long distances. You have a recovery point objective of minutes in that case, but then you can tolerate an entire metro region going down. These are some of the capabilities that we are building into Fusion.
Great, thank you, Sumant. Please check out the other demos we have on Spectrum Fusion, including an install demo and then a general overview demo and a demo that goes into more depth on the data protection platform. Thank you very much.